Great. So I was talking about this divide and conquer rule. It's very simple. Decide with your root node, look for the rules, yes or no, divide them successive, like consequently, and then again come up with other feature. By looking at other feature, again divide them, you looking at the yes or no. So you're just, what you're trying to do here is you're trying to create a tree based on some rules. So it's very simple. Let's say you want to go from one location to other location. You will ask a person, say you want to go, say, to place X. Now you will ask a person whether this road will go to place X or no. They will tell yes or no. Based on yes or no, you will take a next decision, right? Similar to that, decision tree also works. It's the only difficult thing in decision tree is how to decide this first root node. Okay. Now for that, we have to go into some mathematics here. Okay. Now, as I already told, the first and foremost question is which feature to select as a root node. You know how to do your decision tree. Python will do it for you. You just need to write one single line of code. Python will do it internally and it will decide which node or which feature should be your root node, right? Python will do it for you guys. But I don't want you guys to just follow it blindly, right? So I always try to give you some mathematical background behind every code when I feel that it comes under intermediate level. Okay. So you all know entropy, guys. Will calculate the disorder in the system. Disorder in the sense different information. As I already told, you have to keep splitting your trees until unless you get the final output as pure. What do I mean by pure? Pure means at the leaf node, all the data belongs to a same class. Same class in the sense, if you look at the previous example, fit or unfit, right? So pure, that is what we call it as. Keep on dividing your tree from root node to intermediate, intermediate to intermediate, intermediate, and then leaf node until and unless you get your final outputs at the leaf nodes as pure. Okay, pure in the sense the data belonging to that particular leaf node has the same output. Very simple. Now, how do we make sure? We can take any root node now, but the problem is we cannot take any root node here. If we take any root node, say for example, if I take the root node as in the previous example, I have taken age. So for example, for age, selecting as an age as a root node, I got, there was one root node and one leaf node, and I have only say one intermediate node. So it is a 3-level tree. For just assume if I had selected some other feature as my root node, then my tree would have 4 levels, one root node, 2 intermediate levels, and then one leaf node. So it's very difficult, and we should always try to optimize our tree. Otherwise, it will lead to some of the problems. And what are those problems? We'll look into later. But it will lead to a problem of underfitting and overfitting. Remember these terms, underfitting and overfitting. But making your tree very big will lead to a problem of overfitting. There is something also called as underfitting, which is different. But let's not discuss that now. I think I've given you a small hint about overfitting and underfitting in my previous session. Did I? Right? Yes. I've given you a small glimpse about overfitting and underfitting, but I don't want to tell more about that now in this session. But what we have to make sure is your tree is not complicated. If your tree is complicated, that means you have more levels in your tree. That means it is complicated. If it is complicated, that means you're trying to solve your algorithm over. That means overfitting in simple English. I'll tell you in mathematical terms also later on, but for timing, just understand this will lead to overfitting. So to reduce this overfitting problem, sometimes we compromise with the purity of output. Sometimes we do compromise with the purity. If you remember, how can a training data set have an accuracy less than 100%? If you remember, I have told that answer. Your training data set can have the accuracy less than 100% by compromising so that your model does not overfit by compromising the accuracy. Similarly, here also we are compromising with the accuracy and so that our model do not overfit. These are some very simple terms, but I will explain you again in the future with the help of examples. But I think I've already explained you, but I'll also explain you with the help of example in the future sessions. Don't worry. What is overfitting and underfitting? Now, you don't worry about this formula much. It is a formula. We can derive it but to derive it again, it is a separate session, so I don't want to get into that. So P is a probability value, okay? I to M, these are the samples, number of records, and you know how to calculate log of something, right? So this is your entropy value, the measurement of amount of disorderness. Based on this entropy value, we calculate information needed, okay? And then based on this information needed, we will calculate information gain. I know it's very difficult to understand with this terminologies. See, tuple has a different meanings, but tuple is something which cannot be changed. So you don't worry about this, all the terminologies. What you have to understand is how to decide your root node. And root node is dependent on your information gain. So if a particular feature, if x1 has more information than x2 in terms of influencing your output y, then x1 would be considered as your root node. So don't worry about the terminologies. These are the formulas which we'll be using in next slide. Then you will understand in a better way. Yes. Say in this case, I have taken a big example here. Buying a computer is our output, and x1, x2, x3, x4, these are the 4 input features. So now, say if I decide age to be my root node, then say I have 3-level decision tree. Say if I take income as my root node, I have 4-level decision tree. If I take student as my root node, I have again 4-level decision tree. If I take credit rating, this might create 5-level decision tree. So 5-level in the sense you got it, right? 1 root node, 3 intermediate nodes, and 1 leaf node. So we have to choose the one which actually reduces your decision tree levels in simple language. And to decide that, we have to take a feature which has more information in comparison with other input features. Okay. Now, if I want to create a decision tree by looking at the age, let's say if I take age, let me quickly do one thing. So what were the features we had? Age, income, student, credit rating. Age, income, student, credit rating. And what was our output? Whether the person buy computer or not. I will explain you the concept. If we have time, we can look into maths. Otherwise, it's a very simple maths also. Okay. Let's say I'm choosing age as my root node. Okay. Now tell me how many bifurcations or branches it can have. Just by looking at the age, tell me. Less than or equal to 31, 31 to 40, greater than 40, right? Less than 30, 31 to 40, greater than 40. Did you understand this, guys? I'm trying to create the tree by taking age as my root node. Right? Yes, very simple, cool. So for less than 30, say for less than 30, how many outcomes we have? You can have high. If I'm looking only with respect to income, I can have high, I can have medium, I can also have low, right? I have all the 3 different possibilities, low, medium, high. So now I'm looking at income now. High, medium, low. Okay. This is something similar what we have done previously. If you look into this, age, whether the person age is less than 30, yes or no. Okay. If it is yes, does he eat pizza or does he not eat pizza? Okay. Simple. Similarly here also, in this case, we have 3 outcomes here. It's not about yes or no. It's about 3 outcomes here based on the income. Now this is very difficult. You have to understand, it becomes very complicated if I draw this tree. If I keep drawing this, you will notice it will become very complicated with respect to income. Similarly, for 31 to 40, how many outcomes do I have? High, low, medium, high. I have all the 3 outcomes. Okay. Similarly, for greater than 40, low, medium, I have only outcomes as low and medium. Okay. I have only 2 outcomes. Did you understand? So far so good, guys? We are done with the income. Now less than or equal to 30, with income high, what all possibilities of student we can have, whether this person will be a student, yes or no. For less than or equal to 30, with high income, we know it has only no. With less than or equal to 30 with medium, again it has no, but it also has yes also, right? So now what I will do, with less than or equal to 30 with high, we have noticed it has only no. So it has only no whether a person is a student. With less than or equal to 30 with medium, it can have either no or yes, both, right? It can have no, it can also have yes. With less than or equal to 30 with income low, it has only yes. That means income is low, age is less than or equal to 30, a person is student. So it has only yes, right? So far so good. So we have completed for less than or equal to 30 for income and student, right? Now for less than or equal to 30 with income high, we know that the person has only one rule which has not a student. But again, the credit rating has a two outcomes, fair or excellent. So now this no will be divided into fair or excellent. See, I'm drawing only for one branch. See how difficult it is. Now, when a person is having an age less than or equal to 30, if the income is high and if he is not a student, his credit rating is fair, then he will not buy a computer. Similarly, when the age of a person is less than or equal to 30 and the income is high and he's not a student, his credit rating is quite excellent, but he still doesn't buy a computer. Okay, making sense? So our output here would be no computer, no computer, right? So far so good. Understand this. I have taken only first two records with less than or equal to 30 and I've proceeded, and then you have noticed that how difficult it is. Now when I have less than or equal to 30 with income high, he's not a student, he's not buying a computer. Whether his credit rating is fair or excellent, he still doesn't buy a computer. So there is no use of this, because the outcome can directly be come out from this, that he will not buy a computer. No buying of computer, right? There is no need of looking at the credit rating. Now what I have done here, I have done only for one less than or equal to 30 with high income, with not being a student. I got a very pure solution that he will not buy a computer. With a pure solution, that means the output has the same outcome, that means no. Similarly, I can do it for all the remaining branches, but think manually how much time will it take to get all the pure outcomes. So if I go ahead and get the pure outcomes, the first thing is I'm overfitting the problem, because I'm over calculating. It's like a overdoing something, right? Something like that. So it's overfitting. You're trying to fit your machine learning algorithm over. At the training level, you're overfitting your problem. It cannot guarantee that for the test data set, it will work in a similar way or not. It cannot guarantee that. So sometimes we have to compromise with the purity or accuracy with this overfitting. Okay, making sense? What do I mean by that? Compromising. Compromising in the sense, what I will do is less than or equal to 30. If you notice, there are 5 less than or equal to 30s, and we can notice that 3 has no buying a computer and 2 has buying a computer. So what I will do, I will directly stop my tree here itself. Less than or equal to 30, I will stop my tree here itself and say not buying a computer is our output. I know this output is not correct for all the 5 records. It is validating quite good for 3 records, 1, 2 and 3. But for this and this, it is not validating properly. But then, right, how system decides. So first of all, how the system decides that you have to tell to the system. It will try to achieve good accuracy, and then you have to replicate the same thing on the test data set. Okay, and then only you will come to know that it is overfitting, right? Then only you will come to know that if our algorithm is working fine for training data set, it is not working fine for the test data set, right? Then only you will come to know it is overfitting, right? So that's a different case, how system decides where to stop. But before that, we have to understand, can this tree be modified in a different way so that I have very less branches? You have to understand that, can we change this tree and reduce the number of branches? Can we do that? That's the first question. And for that, we have to decide what will be the root node, because here the root node had very much lot of branches. If I had taken, say, if I had started with student or credit rating, it would have bifurcated only into two, yes or no, fair or excellent. So that's the first question. What should be the root node? That's the first thing which we have to solve. And then once you start coding, you will come to know how system will decide when to stop, where to stop. Okay. And yes, system or the Python libraries are so robust that it will calculate all this maths at the back end and it will decide the correct root node. Okay. But how does it do? Let's look at the mathematics behind that. Okay. Now we have two classes: buying a computer, not buying a computer, right? So we have 14 records. Probability of buying a computer with yes is 9 by 14. Probability of not buying a computer, it's 5 by 14. Did you understand this part? Right. Now let's calculate the entropy. Entropy is the amount of disorder, right? Measure of disorder. Now what I am doing here, total there are 13 events. We might have to change this. How many no's? 5 no's. So 5 by 13. And this would be 8 by 13. Okay. You can do the corresponding calculations, guys. Okay. So now let's calculate the entropy. You can change these values as per the same. Okay. You can do that now. Okay. So let's calculate the entropy. Now, what is the entropy formula? Summation of probabilities log probabilities, denoted by information of D. This is entropy actually. Okay. There is some misprinting here. I will change it and I will send it again. Let's look at the formula itself first. So entropy in D, sigma minus sigma of probability of yes and probability of no, right? So probability of yes 8 by 13 log of probability of yes 8 by 13 minus probability of no is again 5 by 13 log of 5 by 13. Okay, you can calculate these values. Okay, I have calculated based on 14, so you can calculate it now. Now what is the information gain if we split on age? That is a problem which we need to solve. Okay, now for age, how many different bifurcations we have? Less than or equal to 30, 31 to 40, and then greater than 40, right? Now, how many positive events we have for less than or equal to 30? Positive events in the sense, with less than or equal to 30, how many yes we have and how many no we have in our output? With less than or equal to 30, we have 2 yes and 3 no's. Similarly, for 31 to 40, we have 4 yes and 0 no. For greater than 40, so this is the table what we have, right? Now what we have to do, we have to calculate the second term. Second term says what is the information value. We have to calculate now. Okay, let's do one thing. What I will do, I'll just change these values and then I will share it again. Otherwise, you guys might get confused with 14 or 13. So what I will do, I'll just try to change this and then I'll share the values with you, because I don't want to confuse you. Okay, but what you can do is just try to create one decision tree with respect to age first as a root node, income as an intermediate node, and then student, and then credit rating. Try this today. Tomorrow I will exchange these values with respect to 13, and I will tell you to create one more decision tree based on the information gain value. Okay, if I want to explain this thing, it's quite simple to understand, but I don't want to confuse you now because this 13 and 14 will be creating a confusion. So let me change these values and then I'll share it with you tomorrow, right? Because I will add one more row. Instead of changing the values, I'll add one more row tomorrow and then I'll share it. Okay, so for today, your task is, if you can take the quick snap of this table and try building a classification tree with age as a root node, and then income, and then student, and then credit rating. If you can do this, I know it will take one full page, but if you can try this, you will understand how things will change here. If you don't draw those trees, no, it will be really difficult to understand how root node is very much important. Okay, so it is 9,5. Okay, so meanwhile, what I want you guys to create one decision tree with the help of age as your root node, income as first intermediate, student as second intermediate, credit rating as your leaf node. Okay, so what you have to understand here is how decision tree is working. It is working on your branches. It keeps bifurcating until unless it goes to an output, common pure output. Okay, now, so again I have imported NumPy, Pandas, Matplotlib. Okay, and I have imported, so let's run this. I have imported one data set directly from the Skill-Lync library. So Skill-Lync library has lot of machine learning libraries. So machine learning library, as I told, Skill-Lync is a core of machine learning, which has all the libraries of machine learning. It also has different data sets. So for that reason, I have directly imported one of the data sets from the Skill-Lync itself. You can import some other data set. You can import the assignment data set which is already there. You can import the same data set itself. Okay, so I have imported that data set, created a data frame out of it, and then you don't worry about this because I am working on the images, which is unstructured data, but you will be working only on the numerical data, so you don't worry about that. So I have a pandas data frame now. So now everyone knows how to create a pandas data frame now. If you are importing any CSV or Excel file, assign that to some variable using pandas. Once you have created a pandas data frame, what I'm doing on 91st line. So in 91st line, we are splitting the data into test and training data set, right? And with what percentage going into training data set and test data set? 80% of it going into training data set, 20% of it going into, right, test data set, using this test size equal to 0.2, which is 20% going into test data set. What is this importance of random state? Remember I told you, right, ensuring repeatability in the random selection or sampling. Now we are splitting the data into training and test data set, maintaining that consistency. Okay, now as I always tell, there is only one line. Just give me a second, guys. I think in today's session there is something missing, right? So again from Skill-Lync, we have to import tree, like we have done for linear regression. Remember, from Skill-Lync we have imported linear model. From linear model we had linear regression and logistic regression. Similarly here we have to import from Skill-Lync, import tree, and from tree we are using decision tree classifier, right? It's just a few lines of code, that's it. You don't have to worry about this. Let me comment this. This will be there tomorrow. Okay. Now same thing, model.fit. What we are doing, we are training our model on training data set, and then we are predicting the accuracy on test data set, and also we can predict the outputs based on the predict function on X. So in this line, I am finding the accuracy of the model with respect to test data set. Now we already have the Y actual, which is Y underscore test. Here I am trying to find the Y predicted values, right? Which is output is yes or no, right? And based on that, what we will do? So in this case, for example, our output was buying a computer, yes or no, right? Which is 1 or 0, right? So 1 or 0, 1 or 0s are our actuals. We are predicting those values, right? Whether our output is 1 or 0s. So for some cases it matches, and for some cases it does not matches. And if you remember from the last session, I told you confusion matrix. So we have to draw that confusion matrix and then we have to calculate that accuracy. But Python has an inbuilt feature which gives you the accuracy directly by using dot score function. In all the algorithms, if you notice, all the lines are common except for this line, right? So now once you run this, you will get your predicted outputs. You will get the accuracy of your model, decision tree model. Now if you remember, I have told you something called as confusion matrix, right? Now how to visualize that confusion matrix? Do you remember the confusion matrix, guys? Actuals and predictions, 1 0 1 0, true positive, true negatives. If actuals are 0 predicted as ones, this is false positive, this is false negative, right? If you want to, yes. So if you want to visualize that, I think I've told you this also. You have to just write from Skill-Lync, you have to import matrix, and in matrix there is a function by name confusion matrix, and confusion matrix will be created on what? Actual output and the predicted output, right? So and then you can print this variable which is CM, in which we have confusion matrix. By this, what we are doing, we are predicting the accuracy of our model. Okay, now so far so good. I am getting the accuracy of this decision tree model. There would be a question when to choose, like both decision tree and logistic regression are working fine, right? Both are working as a classification model, classifiers. So then when to use logistic regression and when to use decision tree? See, on the same data set, I can also use decision tree, I can also use logistic regression. Then how do we decide when to use logistic and how do we decide when to use decision tree? If there are many classifications, we use decision trees. Okay. So this is a rule which you have to understand. In the machine learning, there are a lot of algorithms for doing the classification. Tomorrow also you will learn one more algorithm. But how to choose which algorithm we should perform is very complicated. So in industries, what people do, they will start with logistic regression first. Why? Because logistic regression is quite simple to understand. By looking at the coefficients, you can interpret the results. But in decision tree, it will calculate the trees at the back end. But in the logistic regression, you can always find the equation and then you can interpret the results. So it will be easy to interpret the results in logistic regression. So what you can do in future also, you should make sure that you can use 2 or 3 algorithms for one particular problem and then try to look at the results which is giving the better results. That one you should go ahead with. Okay, making sense? Right. And the next thing which I wanted to discuss, you cannot implement your algorithm directly on this data table. Incorporate your coding on this table. Why? Because we have categorical values here, right? So what you have to do? You have to convert this credit rating fair as 1, excellent as 0. So you have to convert this using if-else loop. You can use if-else or you can use one-hot encoding. You can use label encoding. It's up to you. But if-else would be very easy to understand, right? You can also use one-hot encoding. It's up to you. So 1 and 0. Convert credit rating into 1 and 0. Now how do you convert the column of income? 1, 2, 3, right? 1 as low, 2 as medium and 3 as high. Similarly, you have to convert the column age less than or equal to 31 31 to 42 greater than 43, label encoding, right? I'm not constraining you guys, it's up to you. And then you have to convert your output also, yes or no to 1 and 0. Okay, so now you understand how to convert your this categorical table into a numerical table, right? So first you have to do that, and then on that data frame you have to split the data into training and test data set, and then you have to apply decision tree model. So any questions apart from that root node thing? Any questions? Because root node thing will be clear tomorrow with the help of this slide. Information gain means, for example, this one, say you have this data table, right? Now you have this output. This output is influenced by a lot of parameters. X1, say X1, X2, X3, X4. Now, if you remember, in linear regression, there was something called as R square, coefficient of determination. But in decision tree, you don't have something called as R square. Here we have information gain. So what this information tells us is how much information is gained with respect to this column age in determining the output. For this column, if I'm calculating the information gain for income, then information gain means how much information is gained while predicting the output with respect to column income. Similarly for student and for credit rating. And that we have to calculate for all the 4 columns. We'll be calculating the information gain tomorrow. So for example, if we get the information gain of income greater than say student, let's say tomorrow you will see the values, like we have the gain value for age here, you will see the values for income and student. Let's say you have the values for income and student, and if you notice income information gain is greater than student, then that means income feature is more significant in predicting the outputs than feature student, right? So, and based on the information gain only we decide which will be our root node. So that we will be seeing tomorrow, and that will also clear your question where to stop the tree. So tomorrow we will be discussing half an hour on this slide only, so that you can understand this in a better way. But meanwhile, please try to draw the decision tree for this table with respect to age as a root node, and then income, and then student, and then credit rating. You will see how much difficult it is to draw the one decision tree for simple data set. Okay guys, so please complete the challenges from first week to 4th week, okay? Because all those challenges are more of mathematical, so please try doing it. Thank you.